Good morning, everyone. This is Alex Lee with Cantina. I'm here with Dave Fox, our Director of Technical Architecture, NE Design. Good morning, Dave.
Good morning.
We're very excited to have everyone on the line and hearing Dave's latest research and input on how software isn't a building. I'd like to turn it over to Dave to get us going with the presentation itself. Please be sure to send any questions along through the chat window, and we'll be sure to address them either in the middle of the presentation as it's appropriate or at the end. Dave?
Thanks. So my name is David Fox, Director of Technical Design here at Cantina, and I'd like to talk about designing technical architecture for change. The agenda here, I'm just going to touch upon the analogy between buildings and software and this idea of architecture. I'm going to talk about the tension between malleability and complexity in software, and the barriers to change in software and what the solutions are. So first I'd like to talk about architects. There's this, the word architect in the context of software development is very charged. It has this sort of self-important ring to it, and people generally think an architect steps in and draws a bunch of boxes and lines on a whiteboard, convinces management to buy the enterprise software, and then leaves. Then the developers on the project are left to build the software without much direction and end up having to work around problems themselves. Perhaps that architecture doesn't end up actually fitting the problem very well. Actually, because of that word architect, I actually changed my title from Director of Technical Architecture to Director of Technical Design, simply because there's that sort of thought about the word. And the idea that architects don't actually add value has led to a lot of sort of off-the-shelf architectures of popular web frameworks, and the idea that upfront design really isn't needed. And there is some truth to that stereotype, unfortunately, but we should seek to change that because the role is very important. Building architecture actually implies this extensive upfront design, because buildings are hard to change, and once they're built, mistakes can cost millions of dollars to rectify. You can't just pull down a wing on a new building and build another one. It takes a lot of manpower and money to do that. But on the other hand, we've been building buildings for thousands and thousands of years, and we generally know how to do it, and we do a very good job about planning up front. In software, we've actually only been doing that for a very short time in comparison to building buildings. And so even if we have a good idea of how to build software, it usually ends up being different every time, and there's new challenges to overcome. But software isn't actually bound by the same rules as buildings. We aren't constrained by physics, and we can change software much, much easier. And we need to make software changeable so that it can evolve with the domain, but also that we can counter bad emergent behavior. So even in buildings, we occasionally fail, even though we've done them, for thousands of years. And just like software, there can be emergent behavior that we don't anticipate. This is a picture of the Canary Wharf walkie-talkie building, where that concave shape actually started reflecting the sun and melting some cars. This was an effect that they didn't anticipate when they built that building, and something you can't always protect yourself against. So the best thing we can do is actually to make it easily changeable and to rectify the problem. And as it turns out, this Canary Wharf building wasn't actually that hard to fix because the windows are modular, and the building said that it wouldn't actually impact the cost. So let's start by asking the question, what makes software hard to change? And if we can identify some of those reasons, we can come up with some recommendations that hopefully go beyond the latest fad to hit the hype curve. So I'll start with this quote. This is Ralph Johnson talking to Martin Fowler in the article, Who Needs an Architect, that Martin Fowler posted. The link for that will be in the slides at the end. And it's if you pick any one aspect of software, then you can make that easy to change. But making everything easy to change makes the entire system very complex, and complexity is what makes software hard to change. I think this quote is really fantastic because it illustrates the tension between trying to make something software malleable and adding to that complexity. You do need to add moving parts to make software changeable, but adding those parts makes it more complex, and complexity hinders change. Fortunately, complexity in software is very well understood. It's very well studied. There's a lot of techniques to overcome it, and yet development teams continue to create software that resists change. We want to design software and use frameworks that don't seem enterprisey, and yet many of these enterprisey features and unnecessary layers are exactly what makes the software able to adapt to change. So what are the barriers to change? I'm going to talk about some of the barriers to change that I've seen in my work over the years and some recommendations that you can prevent or overcome them. You'll notice that quite a few of these seem non-technical, and that's because it's important to realize that change in software is not just technical, but an environmental one as well. Everything from your team structure to budget allocation and legacy systems are all part of what makes systems hard to change, and it's important to factor all of these things in. Some of the recommendations I have will be technical and related to specific technologies, but I feel they apply pretty generally. So the first one is lack of design. It turns out that you actually do need that architect or designer. Some of these symptoms of this lack of design that you might see is, let's just use framework X before we've thought about the design of the system, or let's just start coding. Maybe projects with no clear leadership or ownership over the design. And that leaves developers left to decide components without any direction. I've seen this many times now, even to the point of in an RFP where a stack, technology stack is being specified upfront as part of the requirements without any thought to what that system design is actually going to be. This is especially dangerous with certain frameworks because they have their own architectural patterns, and those may work for the general case, but not actually support the architecture you end up needing. Being agile doesn't mean that there's no upfront design. It means that we show value often and iterate on our ideas. We still need direction in design, especially as it relates to overall system design. We need to create a system that grows according to the needs of the application rather than the whims of the teams that are developing it. And we want to evolve towards a cohesive design. So our recommendations here are that when you're working on a project, developers have to have some idea of the overall design before coding begins. You really have to sit down as a team and agree upon that design and have a general design and roles of all the components that are going to be in the application. So one of the things that I found that works very well is working outside in and using what's called the walking skeleton. The walking skeleton is a concept from the book Growing Object-Oriented Software Guided by Tests by Steve Freeman and Nat Price. So this is used in a testing context, but it actually works very good as a development strategy, since it basically requires that you sort of chunk out the components of the application and require that the teams integrate those up front, and then work inwards to actually implement the working components. So that's one good strategy that I find works really well, and it actually ends up aiding your testability as well. And often when you have teams of varying skill levels, or even the same skill level with different specialties, it's easy for these developers to stray from the path of the overall design. And so you need that designer to be working with the teams throughout development and ensuring that that design is followed. But not micromanaging, obviously. You're going to accept input from the people on the team, but guiding them towards the stated goal. Obviously on larger projects, a single designer can't necessarily do this, so it's important to delegate and deputize to those developers that you see as leaders. And finally, you really want to choose frameworks based on your architecture, not the other way around. We have this idea that we can just choose some web framework and that's going to work for every case, but it's generally not true. And so for anything that's more complex than the simplest sort of web applications, it's much better to take a look at your design first. Moving on to coupling. Coupling is sort of the root of much of what makes software hard to change, and it's actually one of the things that's the most studied. There's this word and concept that's been being tossed around a lot lately, and it's called connaissance. Connaissance is a software quality metric and taxonomy for coupling. And it's been around for a very long time. It was actually used in an ACM article in '92 by Emily Parrish Jones. and expanded on in the book what every programmer should know about object-oriented design in '96. I'm not going to go into super detail about Connaissance, but I'm going to kind of give an overview. If you'd like to visit connaissance.io, you can kind of get more in-depth, and there's a variety of talks online about this subject. So Connaissance, like I said, is a taxonomy for coupling. And so we have identified certain aspects of code and given names to them that talk about the different types of coupling. So those are the connaissances on the left. And each of those has properties, which you see on the right. The connaissances on the left are actually listed from weakest to strongest. So there's this idea that certain types of coupling are stronger than others. Name being the weakest, and identity, where code is accessing like a singular entity, is the most strong. And there's this idea that there's locality to that coupling. So within a module, you can allow for stronger coupling, but between modules, you really want to have weaker coupling. And finally, there's degree, which is the amount of coupling that occurs in a particular instance. So maybe the amount of references to a particular name. I bring this up as my recommendation is really to learn about the connaissance and learn to identify these different types of coupling, and identify the strong connaissance and refactor that to weak connaissance wherever possible. So just like where, in the book Refactoring by Martin Fowler, where you can identify sort of code smells, identifying the connaissances and being able to refactor them to be weaker. Secondly is adding boundaries between components, particularly foreign APIs, is absolutely essential in reducing coupling, especially between components. As sort of alluded to in that quote, adding layers does add some complexity, but it has a number of different advantages too, such as revealing intent in the ubiquitous language of the domain, which makes your code clearer to understand. And eases the re-implementation of the components where you've added boundaries to segregate them, and obviously improves testability. So I think that though layers may seem enterprisey and though may seem to add a lot of complexity, I think the advantages actually outweigh that in most circumstances. And finally, you really just want to learn and follow good practices such as solid design principles. The next barrier to change is invasive APIs and leaky abstractions. You can see these where dependencies on implementations reach up through layers of the application, or specialized implementation types are exposed in APIs. One example of this is the ORM that we use in Java a lot called Hibernate. And this has a feature called lazy loading, where we can load a collection in an entity lazily, only so it's not pulling the data until needed from the database. But in order for a lazy loaded collection to be loaded into a view, it has to be bound to a session. And the solution to this is using a pattern called open session in view, where the session is open for a scope and bound to a thread. But what that leads to is we have a persistence concern being handled at the topmost layer of the app. Now, the infrastructure for this sort of makes this transparent. Most would argue that this isn't a problem. However, it turns out that if you wanted to change your HTTP layer to use asynchronous processing instead of synchronous, that thread local mechanism isn't going to work for you. So what we want to do instead is always put boundaries between your domain and foreign APIs. This, as I said, has a number of different advantages, and I think it's absolutely essential that you do this wherever an implementation meets your domain. You want to translate those data structures that are used by foreign APIs into your domain, right? Ensuring that the core of your domain remains pure and free of those external dependencies. And finally, using standard types that don't require clients to import any implementation details. We also want to prefer libraries that use open standards rather than ones that are not open, excuse me. Unless the infrastructure is really transparent, we also want to favor designs where boundaries are enforced and don't leak outside the component. In the case of that hibernated example I gave, using a detached session and eager fetching actually fixes that leak that comes out of that layer. And finally, and this is sort of something that I see a lot in Java, is the use of annotations to give hints to certain implementations. I actually prefer to not use those and to use external mapping or configuration, simply because a lot of times those annotations are a separate concern, and even though it has a nice declarative look to it in your code, I kind of like to keep those separate. And then finally, just one good way of using, one good way of ensuring that things such as leaky abstractions in terms of data access, a good way of handling that is also just to model it away, using some of the patterns from DDD and loading aggregates whole. Next barrier to change is something that I like to call dehydration, and it's this idea that we have to be dry at all costs. And dry is obviously do not repeat yourself. Some of the symptoms that you might see is conflating persistence, domain, and presentation concerns. This is something that is pretty topical because it's the pattern used by default in frameworks like Rails or Django or Spring Hibernate, where you have a domain model that's pretty much a mirror of its persistence and also the API that's exposed to the web. It's done that way to be dry, and it works really well for small domains, but it's really conflating concerns and coupling in a number of different ways. It does make it very much faster to develop in the beginning, but often the model which is useful for the API isn't what you want to use for the internal domain, and that may not be the most efficient way of persisting. So that desire leads to concerns from these other layers leaking out. And certainly a change to one results in a change to all layers, and that can have a ripple effect on your code base. This is not to say that these frameworks are bad, just that sort of the default way that they're used in larger scope applications can lead to sort of this monolithic result. Also, we have this the idea of this one big model, and this is a symptom in a large application using a single domain model, which is often tied directly to the persistence medium. This is usually due to a desire for all of the data updates to be synchronous, you know, as seen by the user, or for normalization. But this actually leads to concerns from different parts of the application being integrated into that shared model, and so this model becomes too general with edge cases for all different parts of the application. One of the things you can do is separate that model into bounded contexts. Bounded context is a term from the book Domain Driven Design by Eric Evans, and it's come into prominence now because of the popularity of the sort of microservices architectural pattern, where the services of the microservices architecture are delineated by their bounded context. Bounded context can be used to pull apart the model so they reflect the context they're used in, but you just have to be careful because developers often end up tying them back together by having what's referred to in DDD as a shared kernel being very large. So my recommendations there are don't try to be dry at the cost of strong coupling. Those rapid application design frameworks, which incidentally in DDD's book is referred to as Smart UI, they're very popular and there's nothing wrong with them, but consider the scope of your application and possibly add some boundaries in between those components. There's a number of different talks online, for example, about how to do that in Ruby on Rails. It's not to say that these frameworks can't be used in a more scalable way. And denormalization is okay. the cost of storage is cheap, and though it may seem like duplicated data is hard to keep in sync, it actually becomes much easier once you start moving towards domain events and propagating changes to data at the application level, rather than rather than looking towards the database to keep everything normalized. And also have a look at eventual consistency in your application. The true impact of it may not be what you think. The idea that the user has to see synchronous updates for every bit of data in the application is actually, in many cases, a fallacy. Most of what we experience on the web is actually eventually consistent, so I would have a look at that. It's not something to be feared. And then it's okay to have similar code in multiple places, especially in separate modules. When you externalize a bit of code and use it as a common bit of code, that's yet another dependency, and it will tie modules together. So if we have similar code, it's not necessarily a bad thing to not be dry. Next barrier to change is infrastructure investments. You'll see the symptoms here where, you know, oh, well, we already bought the license to database X, so we have to use that, or our code is written to use middleware Y, so it's hard to change, or we already hired our team for their experience with framework Z. In some organizations, there's even architecture groups that decide on technologies without complete knowledge of the requirements or design of the application. And they're deciding up front on what a full stack is going to look like before the system's even designed. This is very dangerous and leads to a lot of you know, investments which maybe didn't fit the requirements quite as well as they should have. So when it comes to investing in, and not necessarily investing in terms of even cost, so you know, if you're, for example, using a free, you know, middleware or something like that, is waiting until the last responsible moment. And this is basically the idea that we're going to put off making infrastructure decisions until we absolutely have to. For example, one of the ways you can do this is sort of fake it until you make it, and putting off the implementation of components until the requirements are known. One great example of how to do this is with the repository pattern and a simple in-memory database implementation before deciding on a specific database. And what that allows you to do is to flesh out the requirements as the application is built and as your query patterns are realized and as your needs are you know, fully become known. Then you can finally make that infrastructure decision, and it will really match what is actually required in the application. You also want to design in terms of technology classes rather than specific technologies. So this idea that, you know, we're not talking about a specific piece of messaging middleware. We just know that we need certain messaging middleware with certain characteristics, not that we're designing it towards a specific technology. Also preferring libraries over large invasive frameworks and or segregating those implementations using boundaries. And finally, this is one thing that's not really necessary, but using open source software is often advantageous because it's often also free as in beer. And so for general applications, I generally try to prefer open source software over proprietary. And there's a sort of misnomer that, you know, with the larger proprietary solutions that, you know, you get those because you have paid support, but almost all of the larger mature open source projects have some form of support available, even paid support. So moving on to another is team. So team symptoms when it comes to barriers to change. You might hear think our developers only know framework X, or our developers aren't sophisticated to use technology Y, or developers don't want to learn how to write SQL. That would sort of be this, you know, about the sophistication of your team. And then we have the sort of structure of the team where we say, oh, well, the front-end team is responsible for that, or we have to run updates to our database team, or only Steve knows that particular part of the code. These are all things which, where the personnel and the structure of your organization actually reflects some of the problems. For the first three, we want to try and invest in broad skill areas and encourage training in those, not just specific technologies. You want to structure teams so that more experienced designers work on design and modeling with the less experienced engineers and try to bring them up and teach them that design acumen. And you want to have less experienced engineers try to review the code for more experienced engineers and maybe have them walk through so that they can learn. You also want to push your engineers to become more full stack. We have this idea that we're all in specialized areas of development, like the database guy, the front-end guy, the back-end guy. Pushing engineers to sort of bridge those areas helps to give the engineer much greater understanding of how all the parts of the application work together. So you'll hear a lot more these days about developers who are full-stack engineers. And I think that's important for all engineers to really try to get outside of their zone and understand more of the different layers of the application. Finally, we don't choose technologies only based on what the team knows. That can be obviously is an important factor when choosing technologies, but you don't want to limit yourself to only the technologies that your team knows. Developers are generally curious, want to learn more new things, and so I think just limiting that is a barrier. I have this little quote here. This is the very famous Conways Law, which says that organizations which design systems are constrained to produce systems which mimic the communication, basically. And this is effectively that if you have a front-end team and a back-end team, you're going to produce code that has those two components, right? And the communication between those two teams can become a barrier. You really want to base your designs on the problem domain, not on the team structure. You want to shape the team around the problem domain. I realize that can be difficult, especially in like an entrenched department. But just like architecture, you can try to break off a small portion, break off a small, couple team members from each different department and try to have them work together based on a particular bounded context and functionality in a small multidisciplinary team. And that will allow, and you want to have those small disciplinary teams have direct communication between each other. If they have to go through a project manager or some sort of management layer, it slows that communication down. You really want those groups to be able to talk to one another directly. And as I said when I mentioned the walking skeleton, you want to integrate constantly between those teams. So the last barrier is something that I'm sure everyone has heard of, technical debt. This is something that's also talked about a lot, but maybe not necessarily understood completely. I think we have this idea that we know what it is, we know it when we see it. Technical debt is sort of, when your velocity isn't nearly what it was when the project began. Features are added slower and slower. You might be pushed really hard to add features. There's no time to clean up and refactor. You might hear, this part of the code is a mess. We have to rewrite this. It gets to the point where it's the spaghetti mess. But then when we actually go to refactor it, we find we can't refactor it without breaking something. So what are the solutions to that? Well, the obvious solution is to pay down technical debt as you go. But that's not always possible. So if you have to defer paying down debt to complete features, try refactoring just enough to add a feature without incurring more debt. This is kind of referred to as the Boy Scout rule, or leaving it cleaner than you found it. This is a good way, I don't hesitate to use this, but this is a good way to sort of sneak in some refactoring when you you're at a point where management is telling you, oh, no refactoring, no rewriting, we're just adding features. So that's one way of kind of sneaking it in there. Another thing to do is maybe after a feature push, try to push for a cleanup phase where you're going to do some refactoring. All through that, of course, you have to ensure that there's tests in place. If there's tests in place, you can refactor regularly and with confidence. And if it's done regularly, then it becomes a part of development. It's not an extra expense. And finally, you want to prefer that prescriptive refactoring, not rewriting, right? We're refactoring a la Refactoring by Martin Fowler, the book, where we're identifying code smells and we're applying patterns of refactoring that keep the code working while we're improving its structure, not rewriting it. Where generally rewriting is losing edge cases, never really getting all the features that were there in the code originally. So as a review, so when lack of design becomes a barrier for change, you want to do that overall design up front and empower the leaders to guide the developers in that implementation. With coupling, I suggest learning about connaissance, identifying it, reducing strong to weak, and adding boundaries to segregate components. With invasive APIs, translate those third-party APIs into your domain model at a boundary, and try to prevent those leaky abstractions from creeping out. Sacrifice dryness if it reduces coupling, and split up large models by bounded contexts. You really want to reduce the scope of those shared dependencies wherever possible. With infrastructure, wait until the last possible moment and fake it until you make it, so you ensure that those procurements actually reflect the needs of the application. With team, invest in your team knowledge and increase communication. Your team structure ends up being your architecture and the other way around, so you really want to be conscious of that fact. And with technical debt, pay it down as you go so it doesn't grow out of control. Refactoring is not rewriting. It's part of development, and it should be done regularly. And finally, as one final note, remember how we were talking and saying that software isn't a building? It turns out that the idea of evolving architecture isn't just confined to software. There's actually a new trend in building architecture that suggests that it works best when it's refined by its occupants. So perhaps that architect analogy isn't so flawed after all, and maybe we can start using it again. Thank you. Cantina is a Boston-based digital design development agency, and thanks for listening to the webinar.
That was great, Dave. Thank you so much. For those on the line, this is, again, Alex Lee, also of Cantina. We're happy to take some questions. Please post them up. We have a few already, but if you do have questions, pop them either into the chat window or as a direct message to the presenters here. There's a couple that have come through, Dave. We have some time. Maybe you can answer a couple that have come by. The first is, you repeatedly mention adding boundaries and layers to isolate components and allow them to be changed, but doesn't this lead to a lot of unnecessary layers and, in quotes here, enterprisiness?
So yeah, the thing about a lot of these newer rapid application design frameworks is they remove these boundaries to allow for much quicker iteration. But the boundaries between components they do add complexity, as I was saying, but they provide so many advantages, especially in terms of making code much clearer and segregating those concerns so that they can be changed. I think with modern sort of dependency inversion techniques and things like that, adding extra layers, as long as you're creating a good balance, it can get enterprisey, but I think it's a really good strategy.
Excellent. Thank you. A couple more. Yeah, there's a question about how do you split up models based on bounded context?
So the book Domain-Driven Design by Eric Evans, it's a very seminal work, which is kind of some of the things I mentioned in this talk are based on a lot of the concepts in that. To kind of go into how you separate models into bounded context. I think there's an entire book on it, and I suggest reading that book. I can't really go into depth on it, but it's really this idea that if you have a model, those separate aspects of the model can be in two separate models. So for example, you go to the grocery store and you go to the doctor. Grocery store has information about what items you bought and you know, maybe how much you paid, and the doctor has your medical records. But you wouldn't say that those two things should be in the same model, right? But they're still part of the entity me, right? They're related to me. So rather than having a user object that has get medical records method and a get grocery item receipts method, you know, you split those into two separate models because the contexts are different, right? Grocery store and doctor's office. So.
No, that's a good point. I like the metaphor. Since we did end a little bit early, do you have time for one more question, Dave? I think one came through around restructuring a team. The question is, how do you just restructure a team, especially a large one, to suit a new architecture? There was a slide in there that talked about bucketing people who have already made decisions about where they were, what their expertise were, both in middleware and a few other things. But how does that realistically happen?
Sure. So actually, Cantina recently did an engagement that had a large team where it was a very complex application with a client server, sort of Android tablet app on the front end and back end system. And they had split the developers into two big teams, the front end team and the back end team. And what we realized was the communication between those two teams was non-existent. They were very segregated in how they worked, and yet they needed to really work together for this application to succeed. So actually what we did was we started developing another proof of concept, and what we did was break off a couple of the front-end people and a couple of the back-end people and put them right next to each other, had them work you know, right in adjoining desks, and had them work on a particular feature. So rather than working on like a technology or a layer of the application, you have a small group working on a set of features, right? So just like you can break off you know, a bounded context or a server from a large architecture that's maybe too tightly coupled, this is doing the same thing with the team. So just like Conways Law says, it's this type of pulling off a bit of functionality in terms of like a feature set actually works with teams as well. So you can maybe try with a small group of people at first, and then prove that restructuring is working.
Excellent. Thank you. Well, I appreciate all of the time and the expertise on this, Dave. I think it was a very interesting session, lots of great examples. For those of you listening and participating on the webinar, we will be posting this presentation in its full recording on our website at cantina.co. But thank you all for your time and attention, and we look forward to working with any and all of you in the very near future. Thanks again to Dave Fox, and have a great day, everybody.
Thank you.